With the development of our new formatter, Tomtec recognizes there is a need greater than simply transferring samples from cryovials to microplates. There's a need to simplify the process in a well-defined, well-controlled manner to meet the regulatory requirements. It starts with the incoming sample. The simplest method is the use of a pre-barcoded cryovial. At the source where the responsibility resides, the required data is entered into the electronic sample file in compliance with 21 CFR 11. The sample is placed in a pre-barcoded vial. The vial barcode is wanded into the file, one identifying number from the source. The electronic file is transferred to the LIMS. The barcoded cryovial goes to the formatter in any rack position. The formatter retrieves the vial, scans the barcode, and accesses the specific line of processing information from the LIMS for execution. This can be accomplished now. Nalgene is currently supplying externally threaded cryovials with machine-applied barcodes. Nalgene never prints the same number twice, thus there is no duplication of numbers. The high-density barcode may be read reliably by simple machine-mounted barcode readers. Corning plans to follow suit. At some point in time, it is anticipated that the simplicity and the economics of this type of processing will drive the whole system. However, as simple and straightforward as that method is, very few labs can adopt it at present. There are a variety of reasons. The main one is that they do not presently have control over the containers of the incoming samples. Tomtec recognizes this fact and has designed the formatter system to accommodate these present methods. There are physical and mechanical limits on the size and shape of the incoming containers the formatter can handle. The most common container is the externally threaded cryovial. Nalgene, Nunk, and Corning supply cryovials with common external dimensions for several volumes. Other vendors have similar vials. Tomtec can provide special racking to accommodate various vials. However, there are customizing cost considerations involved. Tomtec has addressed sample entry in several ways. The formatter may be programmed directly from the user's LIMS using a comma-separated value file. From this imported file, the formatter software converts the specific data to the formatter work list. Watson, and possibly other LIMS, defines the sample with numbers 1 through 96. The formatter software converts this to the 96-well format, either by column or by row, as the user selects. The formatter simply needs a link to coordinate the specific sample vial with its corresponding line of code from the LIMS. As stated before, reading the barcode accomplishes this link. If the barcode cannot be read reliably, then the link between the LIMS and the formatter is incoming rack position. A manual method is to place the incoming sample vial in the rack position defined by the LIMS. While this can be done, it is prone to error. All 96 in the incoming rack look alike. Operator vigilance is required to achieve reliability. This can be done and is being done. However, there is another way. Tomtec has addressed this with our PSID. The incoming vial rack has a barcode to identify the rack itself. The rack is placed within the PSID. Sensors within confirm the rack is in a known position to receive vials. The PSID is composed of a matrix of laser beams. Dropping a vial through any hole interrupts the X and Y laser beams defining rack position. The operator defines sample identification. This may be simply highlighting the reference line on the LIMS. If manually applied barcodes are on the vial, they may be scanned. A manually applied barcode can be read by manipulating both the barcode and the barcode reader until the acknowledging beep is acquired. Having identified the vial, it is dropped through any hole to the rack below. The electronic file is transmitted to the formatter. This now provides the link between LIMS and rack position. While the PSID may be used at the time of entry to the formatter, it may be also used as a standalone unit for sample management. For example, take the case where an incoming shipment of sample vials has just been received. As the vial is entered into the LIMS, it is dropped through the desired location in the PSID. This simultaneously attaches rack position to LIMS identification. Concurrent with entering the unknowns, the standards and controls are added to the rack in their defined position. The result is a fully formatted rack ready for processing. In this case, a lightweight carrier rack is used. The rack has an identifying barcode that ties it to the file it currently contains. This formatted carrier rack may then be placed in refrigerated storage until it is time to be processed by the formatter. Tomtec has designed a Peltier-cooled rack for use with the formatter. The Peltier rack is designed to receive and hold the carrier rack at 4 degrees C during processing by the formatter. This enables the laboratory to establish stability data for prescribed periods of time when held at 4 degrees C. The formulated carrier racks are either in the refrigerator or in the formatter at 4 degrees C for that stability period. Tomtec has also addressed the issue of standards and controls for the formatter operation. This can be done simultaneously on the formatter at the time of processing of the incoming sample rack. For example, a 12-point serial dilution curve was made using two-fold dilutions at 100 microliters. It required 5 minutes to add 100 microliters of diluent to all 12 wells. Individual transfers were made for accuracy in lieu of aliquoting. It required another 15 minutes to make the individual transfers between wells, using 6 cycles of titration mixing in each well. While the formatter can perform these individual functions, the majority of laboratories will prepare the standards and controls in a batch format. In so doing, records must be maintained on stability over the period of use. The formatter software provides the notebook function. A file is established in the formatter, showing who, when, what, and how the sample is prepared. A batch file is then created. While the laboratory may not have control over the incoming sample containers, they most likely do have control over the vials for the standards and controls. It is assumed the pre-barcoded Nalgene 2 ml cryovials may be used. Assume 100 ml of stock solution is weighed out and placed in a reservoir. A quadra may be used to transfer this volume to 48 cryovials placed in a mirror rack. The quadra would make 3 passes under automated program control to transfer 1.35 ml to each of the 48 vials. After filling, the barcode on each vial is wanded into the batch file maintained by the formatter notebook. This formatter file then tracks the batch over its period of use. It can be used to control the number of freeze-thaw cycles, period of use, or other designated parameters. This presentation summarizes Tomtec's present offering. As we move forward with the formatter concept, we will tailor our products to fit specific users' requirements. We can assist in the minor modifications that may be required to program the formatter from the user's LIM. The objective is to streamline the processing of incoming clinical samples through to the detection in a regulatory environment. Thank you for the time and interest in our products.